Welcome everyone to this session where I'll be talking about microservices, and this is the agenda for today. I'll be talking about software architecture evolution from starting from monolith to service-oriented architecture to microservices, and then we'll talk more about microservices, how and why, and we'll talk about designing the microservices architecture, its challenges and best practices, what tools we have to solve the issues that we face in microservices world, and how they communicate, how different microservices communicate with each other. We'll talk about that as well. And at the end, I have a problem statement as well that we can uh, personally try to solve it based on today's discussion. And then maybe after 10 days, we can again meet and discuss what all solutions you guys are proposing and why. Okay. So this is going to be kind of repetitive of first few slides because we all know we all have been working on monolithic application, and some of us might have worked on SOA application as well, and then we'll see how the evolution has happened across, and we have reached to microservices architecture. All right. So first, let's talk about a monolithic architecture in brief. So this was the original architecture and that we see here, and since beginning we have been using this. Hello. Okay. I have a diagram of monolithic architecture and that we have been using. You can see uh, in monolithic architecture, the entire application is built as a single unit, and it contains all the business logic inside this box, as we can see here. And normally the whole application is developed in a single programming language, and it is backed by usually one database. We can have more than one databases, but usually it's one. In our confirm, we have, I think, another database called Postgres for IoT, but that primarily depends on the confirm database. Right? This is um, and if you have to redeploy your application, you have to restart the application and redeploy the whole application. You cannot deploy the part of this. Suppose you want to deploy the customer service component of your confirm, you can't do that. You have to deploy the complete application. You have to deploy the database changes and every other change with confirm database only, right? And if any wrong goes with any of the components, there is a possibility that your entire application may not work. And if you want to scale a single part of it, say I want to scale my reporting component of it of confirm, you cannot do that. You have to scale the whole confirm application, right? uh, there are
Yeah,
many applications, there are many big applications that are following this monolithic architecture. If we all are using Stack Overflow, that is a completely monolithic architecture. Okay, let's go ahead and talk a bit more about service oriented architecture. Some of us might have worked in this architecture because from this architecture we have started exposing our application as services, right? And this started in late 90s, probably in 1998, right? But the main communication channel you can see between two services, you have, if there are two services in your application in SOA architecture, they talk to each other using this bus, enterprise service bus. This is a type of software platform, you can call it middleware, which works behind the scenes to aid app to app communication, right? You can think of ESB as a bus that picks up information from one system to another. It picks information from here and delivers it here. It can again picks the information from here and deliver it here. But the main problem of this ESP was that it was trying to do everything. Everything means it was doing routing, validation, authentication, aggregation, and many such things. It was that, and that is why it became too bulky and too expensive. And only large organizations were making ESPs like Oracle and IBM, and only large organizations could afford that because this was very expensive, and that is why SOA architecture was not pretty common. Small organizations had never used SOA architecture. And because of this, and there was a need of lightweight architecture so that different services can talk to each other, and a cost effective architecture or cost effective protocol was needed so that different services can talk to each other. So, and that this ESB was the primary reason for the demise of SOA architecture. Though we had achieved polyglot. Polyglot means this application can be developed in different programming languages using different database, and this with services architecture, this can be developed in different programming languages, say .NET Core or some Node.js, and this can have a separate database, and that too, this can be NoSQL and this can be SQL databases. So this kind of flexibility came with SOA architecture, but again, this ESB was causing the issue. And also there was one more problem, lack of tooling, since it came in 1990s, late 90s, and in 90s and in 2000 era, there was not many tools available to support shorter development cycle, and that was also the reason of why many applications didn't choose this architecture. Okay, now let's come to the microservices architecture. Okay, so here, if we talk about the very broad level, this is the um, architecture of a microservice. You can see there are several microservices. You can see here three. This is 1, 2, and 3. They all have their separate databases. They are actually containers. The image is not so clear here, but yes, this is a container. This is a micro. This is the bounded context where this is the service and this is its database. This is the service and this is its database. This is the service and its database, right? Again, there is a API gateway. We'll talk more about this API gateway later on, but you can think these are the clients. You have a console application or mobile application and web application, client application. They are talking to different services via API gateway, and again, different services are even talking to each other uh, using different protocols. So we have sliced a, a complete a full package into different business entities here. Business entities 1, business entities 2, business, or you can say it component means services. Am I clear here? Or
So is it similar to like breaking the enterprise application into different modules? Like in Confirm, can break it into customer services as a one microservice application, street work as another microservice applications.
yes, you can break it, but the slicing should happen on based on the real world. Suppose let's consider our organization as an software application. Say dude is a software application. Now it has several departments, say HR department, departments of finance, customer service department, support department, engineering department. There is a reception, and there are several other departments as well, right? In real world, if you see, these departments are working together also, and they are separate business entities as well. If I have to suppose you have to get the experience certificate, where will you go? You'll go to the HR department. They have all the necessary documents and they can give you the experience certificate. They need not to talk to any other department for this. If you have to get your previous salary statement, you can go to the department of finance. They need not to talk to any other department to give you the salary statement, right? It's a complete business entity in itself. Similar is the microservice. You have to break based on the business requirement. If you break your application into customer services or streetworks, you say, and if both department talk to each other every now and then, and for say for every second call they need to talk to each other, then probably it's not the best slice, and it's not the actually services architecture. You have to slice it based on the business entity so that there is less talking between the two. This should be very small. Yes. uh,
Okay.
why is there any? Okay, so this should be small enough but not small enough. It should serve the purpose of a business, right? If any service is not following the bounded context principle, this is the bounded context principle, because this is driven by domain driven design. In bounded context, everything related to the domain is visible within the context internally, but it's not visible to other bounded context. What DDD says is DDD uh, deals with large models by dividing them into different bounding context and being explicit about their interrelationships. They follow the principle of single responsibility principle. If we talk about HR department or department of finance, they have single responsibility, right? And same should be followed here while slicing your application into microservices architecture. What benefit we are getting out of this is, if you have to deploy it in cloud environment, and if you have to scale one part of it, say scale, suppose right now hiring is going on dude solutions, right? So which department needs to scale up right now? Engineering department is doing its work as it is. Now the hiring department, those people who are involved in, say, taking interviews or are responsible for first round of interview, they are busy at the moment. So that department who is responsible for taking interviews, that department needs to scale up right now, not the whole organization. And this is the benefit in case of microservices architecture. You can scale a particular department, a particular service, or a particular container if need to need basis. The another benefit that it gives you is, again, like SOA. uh, if this is a microservice that can be developed in a programming language, this is the microservice that can be developed in another programming language. If that fits in this case, this again can be developed in another programming language. It can use another database that is completely different from this, and that is completely different from this as well. So there is mixed technology stack in case of microservices. Also, one team is working on this microservice, another team may be working on this, and another team is working on this. So there is complete isolation in development as well, complete isolation in deployment as well. And if anything wrong happens with this application, that team will be responsible, and that team can better look into it. The boundaries are completely isolated, right? So responsibilities are not spread across. So the fixing is easy. There is granular scaling, mixed technologies. uh, any fault happens, that you can isolate which microservices giving you the fault, right? Also, if another benefit is, if there is a new joinee in your team, in Confirm you can see we have Excel sheet that used to take around 1 to 2 months to onboard a new joinee, because Confirm is a large and complex code base. But in case of microservices, there are smaller teams, and their boundaries are limited. Their development boundaries, their testing boundaries are limited. And if a new joiner comes, he or she has not to deal with large code base. He can focus on a particular department, very small department. These responsibilities are limited, and can onboard within a very limited time, very fast, right? Okay. We'll be talking about a bit about 12 factors app. I am sure we all know this, because this is not especially about microservices, whether you're using monolith or SOA or microservice. We have been following this 12 factors, but I'll touch base this because these are critical in case of microservices. These are critical in case of monolithic as well, but they are more critical in microservices world. Okay, I'll briefly touch upon this 12 one by one. The first is code base. What 12 factor app advocates is that every application should have its own code base or repository. There should not be any code sharing between the two apps. And in case of microservices as well, every service should have its own code base. Having an independent code base helps you achieve easy CI/CD process in your application. Right? We already follow this in our Confirm. The second is dependencies. Now it's about explicitly declaring and isolating your dependencies, because the code base of your app is standalone, and it needs to install the dependencies as well. Most programming languages offer a packaging system for distributing support libraries. For example, in Node.js we have package.json. In .NET we have Nugget packages. In .NET Core as well. So almost every programming languages there is support for to isolate your dependencies, to list down your dependencies, and so that you can install it in any environment, being in development or testing or production environment. If you have the list and you have isolated your dependencies from your code outside your code base, you can easily install it as a prerequisite, right? If you Lucas has already given the demo of Docker and Kubernetes. There is a Docker file actually where you maintain your dependencies as well. The third one is config. So anything that varies between different environments, like anything that varies from the deployment environment is considered as configuration. For example, your database connections, your credentials, endpoints, or credentials to external environment such as S3, Amazon S3, or credentials to any external apps, or any application specific information like IP addresses, ports, host names, etc., are part of config. So what 12 factor app says is store this config related information in environment variable. Why environment variable? Because they are pretty easy to change between different deployment environments. Unlike config files, there is little chance of getting them checked into your code base. And that is why it advocates to store your configuration related information into the environment variable. Fourth one is backing service. So databases or message brokers or any other external system that the app communicates is treated as backend service. A backing service is an application or service the app consumes over the network as part of its normal operation. You may talk to your database or your message broker. These are all backend services. And what this 12 factor advocates is, if you swap your backend services, there should not be any need of code change. For example, in confirm database, in confirm code base, we are using Google Analytical tool. We have written this in such a way. If going forward, we change the analytical tool from Google to Microsoft or say any other third party, we need not change, do the code changes in our confirm. What we need to do is we ship that third party DLL, and we need to make the changes in the registry, and everything else will work. So similar pattern the 12 factor advocates, and this is very crucial in case of microservices. Fifth one is build, release, and run. So the application must have a strict separation between these three stages: build, release, and run. We can use CI/CD tools to automate the builds and development deployment processes, and in case mostly we are using containerization or Dockers in case of microservices, and Docker images makes it pretty easy to separate the build, release, and run stages more efficiently. Sixth one is processes. Basically, it's stateless processes, and it's talking about. So any application should not store the data in memory, and it must be saved to a store or even in cache like a Redis. Nothing in memory. And it's in case of microservices we use a REST API. So by adopting REST, it's automatically stateless. So we need not to worry about saving anything into memory. That's already stateless, right? And if even if you need to maintain the state, you can save it in attached resources. What attached resources means, you can save it in Redis. Redis is a cache store that stores the data uh, not in memory but in Redis or in data store. That way, if multiple instances of an application is running, uh, you won't be losing anything. If you store your state in memory, there are chances that a separate instance has spawned, then you may lose that information if you are storing anything in memory. So better you make it stateless or put it in Redis or data store. The seventh one is port binding. So web apps sometimes executed inside a web server container. For example, .NET apps might run inside IIS, and a Java application might run inside Tomcat. What 12-factor app says is it should be completely self-contained, and it must not rely on runtime injection of a web server. Better not to export it on external HTTP environment or external IIS server. It should be bounded within box. Better to use container so that it contains everything, every dependencies, every port, and every hosting environment. The eighth point is concurrency. This talk about scaling of the application, and this principle advocates to opt in for horizontal scaling instead of vertical scaling. Horizontal scaling means an additional instance of your application. Vertical means additional hardware of your system. So it's talk about horizontal. In case of microservices, we already use the concept of containerization that scales horizontally, and that brings concurrency in your application. Ninth one is disposability. What disposable mean? App can be started and stopped at any moment notice. And when application is shutting down, it should shut down gracefully, and it should ensure the correct state of the application. And when it's creating another instance of the application, it should create it immediately, spontaneously. The system should not get impacted when new instances are added or taking down the existing instances as per need. And this is called system disposability. 10th one is development production parity. So this 12-factor methodology suggests that gap between the development and production environment should be as minimal as possible to reduce the risk that can come up uh, related to the environment. And this is the inherent feature of microservice because we use containerization. The same environment that we use in our testing environment, the same gets deployed in the production environment. And that is why there are very few chances that reduces the risk of showing up bugs in a specific environment. 11th point is logs and monitoring. Logs are anyways important to debug production issues, and they are more important in case of microservices because there are a lot of moving parts in microservices. They talk to each other, they talk to our client, and in between also one service talks to another over network traffic. So without log, you won't be able to bifurcate what went wrong. Was there any communication channel responsible, or which service is at fault? So logging is pretty important here. In case of microservices, it is critical. And the last one is admin process. So anything that is part of administration, like spinning of a new server or database migration, so these all should be part of the application, but this process should be isolated. So in case of data migration, the application should not be impacted. This should be packaged separately, right? Do we have any questions on this? Hello?
I think it's like very well explained. The only thing I would like to personally understand is, let's say I want to write a microservice.
Hmm.
Um, what all tools I will require to create end to end a microservice, and I mean try an example of that at my end.
Okay. I'll come to that. I have slides related to that. I'll come to, and these are actually theory parts that are actually
Yeah.
pillars of any software, being it monolith or microservice or SOA, but they are more critical in case of microservice. That's why I was trying to briefing the we already know.
Mhm.
If no one has any question, I have a question for you guys.
Good question.
All right. So can you read this question? How does a backing service apply to microservices? We talked about backing service just in 12 factors. Who is going to answer this? Should I pick someone from the list, or anyone wants to volunteer? Because it's kind of becoming a monologue
I
kind
think
of
second
thing.
one,
Why do you think so?
because it's a essential service which is actually helping the microservice to do its job. It can be, you can say, supplementary service, which is
Hmm.
doing something. Not,
Right, that is true. Hello.
Yeah.
okay,
Okay. All right, then let's move ahead. CP answered it correctly. Well, let's talk about now microservices bit, right? First of all, the term microservices was coined in 2014 by Martin and James. They published their microservices architecture. They serviced their white paper in 2014, and they came up with 9 attributes or principles of microservices architecture. And this is now de facto standard for microservices definition. Again, this is kind of theory part. I'll cover it briefly. I'll touch upon it, each 9 characteristics of it pretty quickly. So first of all, let's talk about componentization, and this is the crucial bit. We have been talking about this, breaking your application into slices, into pieces, into business entities, or bounded context. So it's all about modularity. It's always a good idea to have a modular design of your application. And to bring modularity in your application, there are two approaches. Either first you either achieve it by using libraries. We often use different libraries in our application that that brings modularity in your in your application, or you can make it your application into different components. And components means services, and you call those services and talk to another system to achieve your application requirements, right? So this is all about bringing modularity in your system. Why this will give you independent deployment facility, and you can have a well identified interface. The second is organized around business capabilities. With microservices, every service is handled by a single team, and that is why responsibilities are also isolated. If you talk about a UI or API or logic or database of a service, this all four things are handled by the same team. So responsibilities are pretty much isolated, and that is why the development will be quick, and the boundaries were well defined. Third is product, not projects. We all have the background of products only. So nothing new in this characteristics, because if we talk about traditional projects, what we do there is we deliver our working code base, and the client takes care of, deals with if he or she faces problem with that project, he or she has to deal with it. There is no support provided in case of there is no contract, then there is no need of microservices, right? It's the headache of the customer itself, that he needs to take care of deployment and deal with any issues that may come later on. There is no lasting relationship in case of projects, but in case of product, if you are working on a product, you build it and you run it, so all responsibilities is of the development team, and that is where microservices come to rescue. The next point is smart endpoints and dump pipes. When we talked about SOA architecture, we saw that ESP protocol. ESP was responsible for talking between the two services. It was trying to do almost everything, from verification, authentication to logging and monitoring everything. And that is called smart endpoint because it was trying to do everything. But microservices advocate dump pipes. What it does is it it looks for solutions that are already available in the market. It uses protocol that are already readily available. Say it uses HTTP or HTTPS protocol. Sorry, HTTP or HTTPS protocol, and also it uses say REST APIs. That's the simplest API in existence, and microservices advocates to use that API. So by using dumb pipes, the cost has been significantly reduced. You're already using the already existing in market, right? The next is decentralized governance. So in case of our application, in monolith application, what technology have we have already chosen, say we are developing in Power Builder or .NET, we have to use the same platform for every part of it. But in case of microservices, every service has an independent choice what platform they want to use, what fits them best, what database fits them best, what mechanism they want to use in creating logs. So every independence they do have. This is completely decentralized, right? Again, the next topic also talks about decentralized data management. This is a bit controversial because it advocates that every microservice must have its own database. There should not be database sharing between the two microservices, but this is not always possible. And in some cases, we do need uh, to talk to we do need to have a two-phase commit or talk to different databases and have shared databases. But this is discouraged in case of microservices, and we try to make data management decentralized as well. uh, to c- uh, to to make it decentralized, we may have some kind of data duplication, but it's always it's never a good idea to update multiple databases in one go, because this will bring you many ugly mechanisms like distributed transaction or two-phase commit, and this will make your system extremely fragile, and it will bring a lot of complexities, which will be more complex than monolith and a single database, and this will kill the purpose of microservices. If you are going into distributed transaction or two-phase commit, and there are chances that your data may not be consistent across applications. So brainstorming should be done while designing the system, while slicing the system into many bounded contexts. All right. In infrastructure automation, yes, in CI/CD process, or if you want to have a shorter development cycle, shorter deployment cycle, the infrastructure should be automated, being it unit testing, functional testing, or acceptance testing, integration testing, or UAT or performance testing. Every bit of it must be automated, and this way only you can ensure that there are not infrastructure related issues or application related issues. For there are a lot of automation tools available like Azure DevOps, GitLab, Jenkins, that will help you in this to achieve infrastructure automation. The second last is design for failure. So with microservices, there are a lot of processes and a lot of network traffic involved. There are a lot of moving parts, and that is why a lot can go wrong. So 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 extensive logging and monitoring is required in case of microservice architecture. Your application should be designed to handle failure. And the last one is evolutionary design. When you're breaking your monolith application into microservices, there should not be any hurry, and it should be gradual, pretty gradual. You can start small, and then you can build up, build your microservices separately. I'll talk more about this. How can you, what all approaches we can take while breaking a monolith application into microservices. All right, so I have a small diagram here. In a nutshell, you can see this is the microservice, and it has its own database. What it does is it provides an API interface. Now it depends on other APIs as well. It consumes as well. It produces. something to be consumed. It has its UI as well, and that may render in another UI template. Right? This is in a nutshell a microservice looks like. It's a bounded context. It's a business entity in itself. Any questions so far? Hello.
No, I think theoretically it is like it makes sense.
Okay, I think I have another question. If anyone can answer apart from CP, the difference between microservices and service-oriented architecture. Who should I ask this? Complete silence.
I think who is awake?
I can give it.
all of the
I'll,
above लग रहा है all of the
I
Uh-huh.
think first one, I don't know. And
No, I think Sabbar is right.
okay,
सभी तो सही हैं.
सभी सही है
Mhm.
That's
Yep.
the best option you can choose.
नहीं नहीं so architecture you can follow everywhere, right? Being it monolith or anywhere.
Mm.
Okay.
right.
यार participants हमारे कम हुए हैं क्या? From 16 we have it's now 15 only.
Maybe.
All right. Okay. Okay. इसमें theory part आज ज़्यादा actually. Actually starting में हम एक working solution पे जा नहीं सकते थे. That is why there is more theory.
I think with the approach you are taking is fine. I think that is making more sense, and people will be able to follow when we will do the practical. So I'm like happy with the time you are taking to explain all the things, because I
Okay.
will be able to relate in the practical once I'm able to understand these concepts. I'm not sure about others, but I hope they agree on the same.
Okay. 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 So let's discuss about architecture process of microservices. These are the steps we follow while architecting any application, being it monolith or SOA or microservices. We first understand the requirement and then non-functional requirements, and the highlighted ones we map the components in case of microservices. While mapping, we already talked about componentization. We break it into different services, different business entities, and we define the communication pattern between those services, how they are going to talk to each other and how they are going to talk to client. And then we select the technology, which technology we are going to choose, and then we design the architecture, we document it, and then we support the team. These are the steps that we follow. So we'll be focusing on the one third part, and we'll start with mapping, and then we'll go to communication pattern, because this is important in case of microservices. So we'll discuss about how we can break an application or create a new application and from microservices mindset. Okay. So when we map the components, it's basically depend on in four pillars. When we talk about components, component means services. In case of in microservices world, every component is a service. So it's all about defining the various components of your service based on these four parameters. Right. When we say business requirement means it's a collection of requirements around a specific business capabilities. I have uh, given you the example as well. If you talk about a commerce system, e-commerce system, uh, it has been broken into four broadly services: inventory, orders, customers, and payments. If we see the business requirement of orders, so what it does is what order department in real world does, it manages orders. Manages means The functionally it does it tries to add or cancel, or add order or cancel order, and calculates the sum, the money. And what data entities it has? It has shipping addresses and the order table, right? And in case of data autonomy, anything related to item or customer, it has all the information in order database. Say for example, if I want to talk to orders and I want to ask a question that retrieve all the orders made by me in last week, it will give me all the details without asking this to anyone. It need not to talk to inventory or customer or payments. If I ask this question that retrieve all the orders made by me last week, or if I ask the question that retrieve all the orders uh, by users aged 30 plus, what will happen in that case? It will have to talk to a different service called customers, because the age of the customer is stored in customer services, right? but but that has nothing to do with orders. So if business entity wise we want to break it, we can break it orders separately and customers separately, because they need to talk to each other definitely, but not pretty often, not for every second call. Order is an entity in itself, customer is a business entity in itself.
But they
And
will
best,
interact because every customer
yes,
will have an order. So whenever there is an order, there will be a customer.
right. But you don't need to have age of the customer, you don't need the user ID, you just need the user ID of the customer in case of orders, nothing else, right?
Right. But suppose I have a query, I wanted to know as a business manager, I wanted to know which region of NCR has maximum transaction during maybe Chhat
Right.
area, but not the Gurgaon area. So in that case, I need the customers as well as orders.
Correct, that is true. I'm coming to that as well. So as a customer, you are more, your queries will be bounded to this order, right? But you said as a seer, right? Or different administrator may need to talk to different services, and based on that you need aggregated report or aggregate information, face information from customer as well and orders as well, so that I can see the trends. This is what you are saying, right? For that, what you can do is you can make another service that is called aggregate service, that will talk to order as well as customers, and then that will give you the input. But
And that
that
will
is
have its own data.
right, that may store its own data if need be. If that is too frequent, that can store duplicate data in its database, that is okay. But if it's not that frequent, then there is no need to store database, there is no need to duplicate the data in that case.
So it should be, the decision should be taken wisely.
Breaking into different components should happen at the initial stage of the designing phase, and that should depict the real world. As I given you the example of Dude Solutions or any organization, if you go to MTNL office or say any office, departments are different, they talk to each other definitely, but not for every other decision, right? There may be an front office that talks to HR as well as finance department. If you want your salary slip along with experience certificate, they can talk to both departments, HR and finance, and they will give you the necessary evidence or certificate. That's different service reception, right? But that does not mean HR and finance are not two separate business entities. They function independently, but they may talk to each other. And this is how in inspired from real world, the breaking happens in microservices world. You can see here exactly similar pattern. These are the departments of any mall, any big shop.
Right.
And this is how it is being developed in software world as well.
With just a time check, you have only got 10 minutes left.
uh, 10 minutes, no, it's an hour session, no?
Yeah, in that only you have got 10 minutes.
Oh,
He's too lost in teaching. He has lost track of time.
oh, I've a lot to cover then. Ah.
Next session you can cover. Just ensure that in this session you can take it to the logical end.
Okay. After mapping part, once we have sliced your application into different compartments or components, now the communication should happen between different organ communication, I said, they need to communicate to each other, right? So first is cross-cutting services. There are many services that every component of your application needs, like logging or caching or user management. Every service of your application needs this. So this again could be a different service. There you create a service that handles logging, create another service that handles caching, create another service that handles user management, and every other service will be talking to that service for handling the logging, caching, user management kind of stuff, right? And the second bit is communication pattern. This is all about how one service talks to another service, how client talks to different services. I'll talk more on this. So these are the common patterns that we use to establish communication between different services. There are three main patterns: one-to-one async, one-to-one sync, and pub sub or event driven. Let's first talk about one-to-one sync. So what happens in this case is one service may directly talk to another service. Suppose order has to talk to payments, right? It can make direct call to payments and talk to each other. It's a direct connection, and this is usually not recommended. Why? Because if every service wants to have direct connection between each other, so this is how ultimately diagram will be plotted. It will create a spider web like structure. And if for say any service goes down, say rate once, then what will happen? This will cause a ripple effect. In a distributed system involving multiple databases, you know, uh, uh, the direct connection between two services is not advisable, right? What is the solution then? What solution that microservices suggest is bring an API gateway into the picture. Now if client wants to talk to any service, or any service want to talks to another service, it will only talk to the gateway, and gateway will be responsible to bring every services on board, and it will facilitate the communication between two services, or communication between client and and any other service that they want to talk to. And how the API will be able to manage that? How the API will know the IP addresses or port of services? Because they are continuously changing. Any new instances can spawn up, or any instance is shutting down. So these are completely moving parts. Their IP addresses and ports are being changed every now and then, very frequently. So what it does is it 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 maintains a service discovery or service registry. It's like yellow pages phone book directory. It maintains it talks to a service discovery or service directory, where service name and its IP addresses and port binding is maintained in a separate database, right? So if any service is going down, or shutting down, or new instances is being created, it gets updated into the service registry, and it gets updated into the service registry by two methodology. Actually, the service itself can update its status, or its IP addresses and port into the service registry, or service registry itself can listen to different events that an instance is being created, or an instance is shutting down, and based on that it can update its directory, and then gateway will read from there, and will make the calls to different services on need basis. The headache is not on the services. The service need not to worry about what is the address of another service that I want to talk to. I can always go to gateway, give me that service endpoint, that is now the instance that is now running, and this will give me the service address, and I can then establish the communication between that service and talk to that service, right? So by bringing API gateway into the picture, many problems have been solved. Now the service, this is not the burden of the service, how I need to maintain the different addresses of any other service that I want to talk to. So we talked about gateway, and we talked about service discovery as well. And there is a tool called console that gives you yellow pages like a structure that gives you a way where you can store uh, different service and its IP addresses and port easily and fetch it from there. The API gateway will talk to this service registry, and API gateway not only do this, API gateway is responsible for many other things as well, like authentication. For authentication, every service need not to worry about. This can be handled at gateway part, right? And gateway does load balancing as well based on the service discovery. If any instance is if any new instance is creating, or any instance is shutting down, so load balancing can be configured at API gateway end. uh, this is not the headache of service itself. Bringing API gateway into the picture, you can give the responsibility of load balancing or authentication, or service registry part, give me the updated address. These all are handled by API gateway. And again, one more thing that API gateway can solve is the insulation. What you can configure here is you can configure, say, HTTPS protocol while you talk to uh, API gateway. But behind the scene, API gateway can manage HTTP protocol, and you can provide the security by via VPC, say, in case of AWS, and then rest of the talking can happen over HTTP protocol. So this gives you many benefits, bringing API gateway into the picture. There is another concept called service breaking. I'm not sure I've written. Yes, service breaker, circuit breaker. Sorry. So this is a pattern. What it does is by implementing this pattern, you can configure a service. If a service goes down, what will happen in that case? You can see here in diagram, one service is talking to another service, and this is talking to another service. Now for time for any other reason, this is giving you timeout, or this is overloaded, or this has shut down. So in that case, what circuit breaker will do is, if you have applied circuit breaker pattern, what it will do is you can configure it to give you cached data. If when the service was running, it can store the cache data from that time, and it will give you 404 along with cache data, if that is the requirement of the business. Or it can check that if a service breaker checks the health report of the service. If this service breaker is attached to this service, this will periodically check the health of the service. We do the same in task processor. We have monitoring threads that does the same thing. When it says that service is giving you timeout, or it's shutting down, it's shut down. So the circuit breaker in our household, what it does, it opens the connection, and that is why when it is open, it means the communication is broken. Now every service that talks to this service, suppose there is a timeout of 1000 millisecond, it is going to take 1000 milliseconds before uh, getting to know that, okay, this service is not running properly right now. So instead of taking 1000 milliseconds, this will see that if circuit breaker is open, it will not invest further time, and it will automatically it may redirect you to the fallback service. If service circuit, you can configure your service breaker in such a way that it can go to fallback service, and then or you can give you the cached report, or it can give you the fallback mechanism, and it will give you the data that you need in as per your business requirements. So we talked about API gateway as well as service discovery, service registry, circuit breaking, and there is one more thing that I wanted to talk about is service mesh. Though we not use service mesh in all cases, but yes, uh, I will try to quickly cover it. If we install Fiddler in our machine and open Fiddler, what it does is it gives you what all incoming and outbound calls are happening from your system or inside your system. Similar kind of a structure is service mesh is giving you. Right? It sits with it may sit side by side to your service or inside your service if you configure it. And what it does is it monitors, it creates metrics, how many calls have been made to this service, how many calls this service has made to another service. It creates metrics, it monitors every calls, create metrics, gives you complete picture. You can actually create a service map via this service mesh. What it does is, hello.
Keep going.
Okay, so when one service talks to another service and it was a failed try, it will again retry it. Right? You can define the timeout as well. How many after how many milliseconds it will give 404 error. Right? So all this configuration, how many retries you have to make, how what is the time of timeout, this all can be configured. And what is the matrix, is this is this service misbehaving, this all can be managed by service mesh. So now this should not be the headache of now now the load balancing, now the service registry part, the updated port and IP addresses, and the number of retries or timeout time. This all should not be your service should not be worried about these many things. There are several tools. There is service mesh, there is API gateway, there is service discovery, there is service registry. These are the tools that are available in microservice services architecture world that gives you hands up while one service talks to another service. Right? While I was talking about service mesh, this can sit in service mesh can sit inside your service or parallel to your service. These are the tools. If you are uh, using sidecar, you can use mesh in case of AWS or Istio or Linkerd, or normally we choose sidecar. It's a platform agnostic with any technology that can fit. And if you are using in process, if you want to make service mesh part of your service, then you can use DDS Foundation. There are various tools available for every solution. So we had talked about just one way of communication, that was one-to-one sync. Now the other bit is one-to-one async. So before this, I wanted to draw some images what we have discussed so far, but I think the time is up, right?
That's right. Yeah, we are
Okay,
already.
so what we will do is if we'll meet next, we will start with diagram. So today's was completely theoretical part. So next time we'll try to create diagram in Paintbrush, and there we'll try to visualize what we have discussed so far.
Okay.
Okay.
Yeah.
So let's end here for today.
Sure.
Okay.
Yeah. Perfect. Thanks.
Okay. I was not able to cover too much in this session.
Mhm.
All right.